Hello students, and welcome to another exciting physics lecture with me, Mr. White. So, what I have for you today is a little bonus lecture, alright? So, because of this whole global pandemic thing, I can't really teach everything that I want to. I had to pretty much reduce it down to the basics, alright? And there were at least two more topics that I wanted to get to in this unit, but couldn't because of the restraints, and that's totally fine. Like, I understand, but like, I think this is some really cool stuff. So, first what I'm going to do is I'm going to do a cool little demonstration, okay? And you can do this at home too, and it's actually really fun. All you need is a little rolly chair, or a stool, preferably a chair, so you don't fall off. And then you need two heavy objects that you can hold in one hand at a time. So right here, I got my theoretical physics textbook, and then I've got calculus. All right. Notice I don't have any biology textbooks. That's a little too lightweight for me. That's a science joke. All right. Don't tell your bio teachers. Okay. And so what I'm going to do, and what you can do, is hold one book in each hand. Switch. Alright, hold one book in each hand, and then what you're going to do is you're going to spin around with your arms stretched out, like so. My hands are actually a little greasy because I just ate dinner. But you're going to do that, and then while you're spinning, you're going to want to make sure that your feet are off the ground, okay? So that they don't drag across the ground, because that's going to affect it. Now, all you got to do is just spin around with your arms spread out, like so. Also make sure that you don't hit anything, right? So you don't break any of your parents' stuff, and they don't get angry at you and me. So like this. So you're gonna spin around with your arms spread out, and then slowly put your arms in, and you'll notice that you'll start to spin a lot faster, and then you can slow down again, and you can even slow down even more by spreading your legs out. And then bring everything back together, speed up again. Okay? Slow down, speed up. Slow down, speed up. Alright? Oh, that makes me really dizzy. Alright. But it's still fun nonetheless. Now, what this demonstrates is a little law in physics that we like to call the conservation of angular momentum. Now, last unit, as you recall, we learned about momentum and how momentum is conserved. Okay, today we're going to be talking about angular momentum and how angular momentum is conserved. Okay, so all angular momentum is, and this is a basic formula, it can get a lot more complicated. So this is just a formula for one mass and one radius. Okay, but for me, there were two masses, actually three masses, actually an infinite amount of masses, right? Because each part of me has a mass and a radius. Mass and radius here, 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 everywhere. So you have to actually add all of those equations up to get the whole picture. But all we need is just this one basic formula to keep it simple. Now, sorry, this is angular momentum. And just like momentum, angular momentum is also conserved. So what I'm going to do, I'm going to set MVR equal to MVR. Now, as you see, I changed one thing. I can't change mass. I mean, I could have let go of the books, but I didn't. But I did change the radius. I had the books at a large radius, brought them into a small radius. Okay? So, what that does, actually, you know what? I like this little thing right here. I'm going to draw a little seesaw, right? So, the after part is when I reduce the radius to make it very small, small r. Now, what happened, right? Mass didn't do anything, but velocity increased, right? We have to sort of keep this balance between angular momentum before and angular momentum after. They both have to be balanced. So if r goes down, V has to get bigger to keep that balance going. All right? So, a good application of this is figure skating, right? So if you've ever seen figure skaters, right, they start skating, and then they start spinning around in a circle. And then, as they're spinning around in the circle, they bring their arms together and probably their other leg too. And they start to spin a lot faster. And then they go out again. Whoosh, slow down. Okay, so now the reason why this happens, or to look at the reason why this happens, I want to do a little bit of analysis with free body diagrams. So what I'm going to do is I'm going to draw the force and also the velocity of the book as it travels. So what I have right here are two separate circular paths. We have a large circular path and a small circular path. And this shows the path of the textbook. It goes from a large radius to a small radius. Alright, and then what I'm going to do is I'm going to draw the velocity, which is always, again, tangent to the path, and then force, the centripetal force, which always points towards the center. And then I'm going to do it again right here. We have a velocity going this way, and a centripetal force that points towards, you guessed it, the center. Now, what I'm going to do is draw the forces acting on a dot in the middle. Again, what I'm going to do is draw the velocity tangent like this, and then centripetal force towards the middle. All right. Now you might have already noticed it, but the one in the middle looks a lot different than the other two. Okay? So before and after, we see that the angle between velocity and the centripetal force is a perfect 90-degree angle. Okay? But here it's a little bit different, right? We see that the centripetal force not only points towards the center, but in relation to this velocity, it's sort of pointing towards the velocity, right? Normally, if it would be pointing like this, okay? But it's pointing slightly towards the velocity. What that does is it causes that object to speed up, okay? So that's actually the cause of this. It just so happens to work out with the angular momentum. Now I'm also going to link a Vsauce video, which also I highly recommend you watch. He's going to do a lot better job at explaining this, but I wanted to do it in a more clear and concise way. Anyways, that's all for today. Stay tuned for another bonus lecture sometime soon on gyroscopes. Anyways, have a nice day. I'll see you later. Goodbye.